All right, notation for repeated integration by parts. So for a few types of integrals, we know from the start that we will have to apply integration by parts many times in a very specific way. So this would happen when you have a, t, or e to pick your u. All right, so let's redo an example. Let's reintegrate the integral of x squared plus 1 cos of x. All right, so we actually just did it. And what we've noticed is to integrate this function, we actually applied IBP once here, and once here. And what was special is that these two are exactly the same. I had d2x and I have sine of x. So what I can do, I can use that to actually skip the middle part. So I'm going to start the same way I did before. I'm going to start with u equals x squared plus 1 because that's a. This one is t, and so my dv, I'm just going to put cosine of x. You'll see why in a second. So I'm not writing that these are equal because then I would have to put dx. That's my dv row, and I'm just going to put cosine of x. All right, so then I'm going to differentiate this part. I'm going to integrate that one. So you take the derivative of the first, integrate the other one. Integral of cosine is just sine. All right, and that's what we got here. Right, now for the second integration by parts, we're going to start here. And so that's going to be my start for the second. And I'll differentiate again. And I'm going to integrate again. Right? When I differentiate the top, I get 2. When I integrate sine of x, I'm going to get minus cos of x. Right? So exactly the same. So this table contains all the information that my 2IBP needed. And so what I'll be able to do is I'll be able to rewrite this step. Sorry, there's a parentheses missing here. I'm going to rewrite this step at once without ever writing the middle one. All right, so if you look at the first term, it's going to be this diagonal here. So my integral is x squared plus 1 sine of x. So first term, this diagonal here, the product of these functions with a plus. Second term, that's this diagonal, but notice that I have one minus in front of it. So second term is going to be that diagonal with a minus. So minus 2x. So you add an extra minus in front, and then you keep whatever you have. So I had a minus here. That doesn't affect it. I just put it here. But I have an extra minus. That comes from the minus VDU. And then my final term is the integral of this final column. So it's a lot like what we had. It's just that you have more diagonals to take care of. And then I have one minus from the first time I applied IBP. I have a second minus from the second time I apply integration by parts. So together I actually get a plus. Right? So plus the integral of 2 minus cos of x dx. All right, so you take all the diagonals and then the integral of the last column. Every time you apply IBP, you get an extra minus, so every time you switch sign. So let's finish this problem. 2x cos of x. And then this final one I can integrate. I get minus 2 sine of x plus c. All right. So let me recap this new notation. So notation for repeated integration by parts, all the ones that imply algebraic, trig, and exponential. No logs, no inverse trig functions. All right, so you start with u and dv in the first column. That's what we had here. Then you differentiate the top row, integrate the bottom row, and you repeat. You're going to repeat until the final column, that's the integral that you're left with, until you know this integral. All right, so in this case, we have 2 times cosine. That's fine, we can integrate that, so we stop. So stop when you know the integral of the product of the last column. All right, once you've done that, now you're ready to write what your integral is equal to. So the integral is equal to the sum of the product of all the diagonals with, and I'm going to start with plus, then switch, so alternating signs. So plus, minus, and so on. And then the last term is the more complicated one. I have the integral of the product of the last column, and you continue alternating signs. So this final one might have a plus or a minus. It depends on how many terms precede it. All right, so in the next section, we'll talk about the special case where you have only trig and exponential. That's going to lead to something that we call the boomerang, and we'll use this method there as well for extra practice.